right? Because again, we have a reasoned faith, not a blind one. And so we're going to look at two major evidences, and that's the rock layers and the fossils. Now let's talk about the rock layers first, because many of us have been taught that the rock layers and other geological structures like canyons take millions of years to form, and we're used to seeing these geological columns, so to speak, that supposedly represent time. So the lower that you go in the rock record, okay, the lower down here you go, the older it is, the older the rocks are, the older the fossils are, and the further up you go, the younger the rocks are, and the younger the fossils are. And that's supposedly how it works. But the question is that really true? Or can these types of things form very quickly under the right conditions? So we're going to watch a short video about the Mount St. Helens eruption that occurred back in 1980. A vast majority of people in this room can remember that. I remember watching it on TV. It was pretty cool. And what that event showed, not just in 1980, but even in the years following, that rock layers and canyons and other structures can actually form quickly under the right conditions, like a catastrophe.
On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present.
Okay, so what this showed us, a lot can happen, right? If you have the right catastrophic conditions, which we did at Mount St. Helens. They talked about these rock layers here. You can see the person at the bottom for an idea of scale. This is a lot of rock, right? And it was laid down in just a few hours. It didn't take millions of years. It just took the right conditions. They talked a little bit about this canyon called Engineers Canyon. This was carved out in 9 hours. That's all it took. Right? It just took the right conditions. So it's great observable evidence that it does not take millions of years for these types of structures to form. Now, they talked about this canyon. It's actually quite similar in layout to the Grand Canyon. Now, it's a lot smaller, but similar in layout. And if you go to Engineers Canyon today, there's a river that cuts through the canyon. Now, I'm going to tell you right now, we know that that river did not make that canyon, right? Because we observed it in the present. Well, I'm going to tell you the same is true if you go to the big one, okay? That river didn't make that canyon either. And that's what you'll hear, that that river whoever carved it out over millions of years. Now, there's lots of reasons why that is totally implausible, but just to share with you one of them, see the sides of the canyon and how steep they are, okay? How many have been to the Grand Canyon? I have. I've whitewater rafted down that part, okay, right? It's really steep because you look up and the sun, it doesn't even stay in the sky very long because it's just, you're so crowded in because those sides are really, really steep. If it was millions of years old, those sides would not be that steep. They'd be, okay, they'd be laid back. They'd be all rotted away. They wouldn't look like that. And so that's just one evidence that it cannot be millions of years old. All right, let's move on and talk about the fossils. And one of my absolute favorite finds when it comes to fossils is that we find soft tissue in dinosaur bones. All right, now, why is that so surprising? Because tissue doesn't last millions of years, right? And even though, and so that's a major problem because all dinosaur bones are dated to at least 65 million years old or older. So as a biologist and someone who has worked with tissues and cells and DNA and proteins in the lab, there's no way they can last millions of years, right? Even under pristine conditions, even when I freeze them to minus 80 degrees Celsius or put them in pure liquid nitrogen, it can be a struggle. You got to be really consistent with it. You got to hope the electric doesn't go out. You got to put, all of these things to keep these things preserved and in good shape. So there's no way that you would expect to see this under a microscope when you look at a dinosaur fossil. Because what are you seeing here? This is bone, obviously, that they're looking at. But what you're seeing here are blood vessels, branching blood vessels. Bone has a lot of them. It's very vascular. What about these little reddish brown structures right here that look really round? Those are red blood cells in the blood vessels, all right? Now, when they first saw this, they were like, no way. This can't be, because there should be no structure left. It should be completely obliterated because it's been millions of years, right? That's the idea. But it's not. It's there. And in fact, if you look at it, this is just one sample. It's stretchy. Okay, and it looks like fresh bone. I actually worked with bone for my graduate study, so I'm very familiar with how this should look. If I didn't know any better, I'd say that's fresh bone, but it's not. Okay, it's from a fossil that's supposedly millions of years old. So I want you to listen to Dr. Mary Schweitzer. She was one of the first scientists to really study this and popularize it, and listen to what she says about her discovery.
Not going to believe this. But when she picked up a small piece to stop the reaction by putting it in water, it stretched, and it sproinged, and it moved all over the place. So we knew we had something pretty unusual.
It appears to be soft tissue. When they look at neighboring parts of the bone, they're even more surprised.
Out popped the blood vessels, and they were pretty incredible. And I said, I don't believe it, that's not possible. We need to do it again and again. It's one of those just goosebump-inducing scientific moments, that's all I can say. And they don't really happen very often.
Blood vessels should not exist in fossilized bone. Many scientists believe organic molecules can't last more than 100,000 years. Yet Schweitzer's bone is 68 million years old.
Or is it? Right? That's really the question. Because she even says, I don't believe it. That's not possible. You need to do it again. She's taken a huge amount of heat for this find. Okay? Huge, right? Because it shouldn't be there if millions of years is true. Now, her lab and other labs, but especially her lab, is trying to find a way. You know what they're spending their time and money on now? Is how these tissues could have lasted millions of years. Well, here's what I don't think they're ever going to find a way that tissues can last millions of years. They're just too fragile for that. You know what the better explanation is? It's only a few thousand years old. Because it was fossilized at the time of the flood. Because it was buried and preserved very, very quickly by a huge catastrophic flood that buried it deeply so that it could not fall apart. It could not decay that quickly. And that's why we dig it up, and that's why we see it today. Right? That is a much better explanation, and it's absolutely consistent with what we would expect to see based on Scripture. Now, creation scientists are doing active research in this area as well. I just went to a meeting of creation scientists where they talked about this in detail. And this is an electron micrograph picture of a Triceratops horn that has been dated to be millions of years old. And what you are seeing here is a type of bone cell called an osteocyte. These are mature bone cells, and they have these tiny little fragile like tendrils that come off of them. It's how they communicate with other cells and the bone. They're very fragile. And there is no way I would expect to see that on something that's millions of years old. They should have all broken off. You shouldn't have any cellular structure at all, but yet that's what you see. And you compare it to fresh bone, it's actually difficult to tell the difference. Again, it's just further evidence that's saying these things cannot be millions of years old, okay? They're absolutely consistent with being only a few thousand years old and formed at the time of the flood. So that's just two issues, okay, in dealing with the flood and evidences for the flood. Obviously, there's many more, but we've answered questions now about these three big issues: the ark, the animals, and the flood.